Hello once again, students. Today we'll be discussing end of unit questions from Unit 10, Measuring Motion. You can see question 10.1. A red car travels 120 kilometer in 1 hour. A blue car travels 130 kilometer in the same time. Which car has greater speed? This is a really easy question. Uh, you know that speed is equivalent to distance upon time. Okay, since there's a constraint on time, uh, red car travels in 1 hour, blue car travels in the same time 1 hour. So this time speed will only depend on distance, because in both the cases time is same. So more the distance, more is the speed, because speed directly depends on distance. Fine. Uh, okay. So blue car, which traveled a distance of 130 kilometer in 1 hour, has more speed as compared to a red car who only traveled 120 kilometer in 1 hour. That was an easy one. Okay, part B 10.1. Runner A takes 45 seconds to run 400 meter. Runner B takes 48 seconds to run the same distance. Which runner has the greater average speed? Okay, same question. Speed is distance upon time. Here distances are same. If you can see, runner A takes 45 seconds to run 400 meter. Runner B takes 48 seconds to run the same distance. So this time's distance is same. So speed only depends on time. And since there's an inverse relationship with time, more the time, less the speed. It makes sense also. The more time you take to complete a particular task, the lazier you are. Fine. Okay, so clearly runner B takes more time. He takes 48 seconds to run the same distance. So definitely runner A has more speed. It has a greater average speed. Okay. 10.1c. A bus travels a distance of 100 kilometer in 2.5 hour. Calculate its average speed. Give your answer in kilometer per hour. Okay. Uh, Once again, where should I do it? Okay, let me do it here. So speed is distance upon time. Distance is 100 kilometer. Time is 2.5 hours. Fine. You simply have to solve it now. I can write it like 100 divided by 25 divided by 10. Fine. It's an easy way of doing this. So that would be 100 upon 25 into 10. 25 1 hour, 25 4 hour 100. So 4 into 10 is 40 kilometer per hour. Fine. A bus travels a distance of 100 kilometer in 2.5 hours. Its average speed is 40 kilometer per hour. I hope I made that very clear. Question number 10.2. A driver can work out her average speed using the instruments in her car. The picture shows the clock and the distance meter at the beginning of a journey and at the end. The distance meter gives the total distance traveled by the car in its lifetime in kilometers. So this is the beginning of her journey. This is the end of her journey. This is the beginning of her journey, the end of her journey. This shows the clock. This shows the distance. So this is like an odometer. And this is simply a watch. It's a digital clock we have in our cars. There is one more that's called as a speedometer that tells us the speed of the vehicle as it's moving. Okay, fine. 10.2 part A says, How much time has passed between the beginning and end of the journey? Okay, the journey began at 9:27. The journey began at 9:27 and the journey ended at 12:27. It ended at 12:27. So that's a really easy question. 9:27 to 10:27 is 1 hour. 10:27 to 11:27 is 2 hours. 11:27 to 12:27 is 3 hours. So it's simply 3 hours. Okay. Now, how far has the car traveled in this time? Now, how far has the car traveled? For that, we'll calculate, we'll just see what was the uh, final reading of the meter, what was the initial reading of the meter. So the final reading of the meter is 22582 meters and the initial reading was 22462. Okay, so if you simply subtract them, that will give you 120 meter. So how far the car has traveled in this time? The car has traveled 120 meter in this time. Okay, so not much. Okay. Calculate the car's average speed during the journey. Show your working. Okay. Now we just in the part B, we saw that the distance this car traveled was 120 meter. Now the question part C wants us to calculate car's average speed. So average speed would simply be equivalent to distance upon time. So distance is 120 meters and time is 3 hours. 3, 4 or 12. So 40 meter per hour. The car has traveled 40 meter in 1 hour. Okay. Question 10.3. A train is traveling at an average speed of 150 km per hour. How far will it travel in 2.4 hours? Show your working. Okay. Its average speed is 150 km per hour. It simply means that in 1 hour it travels a distance of 150 kilometers. In 2 hours it will travel a distance of 2 into 150 kilometers. That's 300 kilometers. And in 2.5 hours it will travel a distance of 2.0, was that 2.4? I'm sorry. 2.4 hours. It will travel a distance of 2.4 into 150 kilometers. And that will be equivalent to 360 kilometers. Fine. Okay. How long will it take, part B says, how long will it take to travel between two stations 525 kilometers apart? Show your working. Okay. So this is a really, really easy one. We know that the speed of this train is how much? 150 kilometers per hour. Okay, so that's 150 kilometer per hour. Okay. Question 10.4. Here are the three distance time graphs A to C. Which graph represents the journey of a car moving at a steady speed? Okay, I've explained this in great detail in the class. but I'm going to repeat anyway. Speed is distance by time. And I also told you that this ratio is basically the slope of this graph, how steep the curve is. Okay, how steep the curve is. So more the angle, more would be the speed. I told you that speed can be represented as a distance time graph, where distance is on the y-axis, time is on the x-axis, fine. And greater the angle it's making with the x-axis, the graph is making with the x-axis, more will be the speed. Okay. Now part A says, which graph represents the journey of a car moving at a steady speed? Now this is a straight line graph, and you can see that in this particular graph, equal distances are traveled in equal intervals of time. So such that the ratio of distance and time is the same throughout. I'll be explaining this in detail in question number 10.5 as well. But yeah, it's actually part A, which represents the journey of a car moving at a steady speed. Fine. Part B says, which graph represents the journey of a car whose speed is increasing? Now look at this graph B. As the time passes, the distance traveled is less and less. The distance traveled becomes less and lesser. Fine. So definitely this is not the graph we are looking for. Have a look at this graph C. As the time passes, the distance traveled becomes more as compared to the time taken. Fine. So this indicates that the car is increasing its speed. So this graph, graph C, represents the journey of a car whose speed is increasing. Fine. Part C says the distance time graph below represents the movement of two cars, blue and red. Which car has the greater speed? Explain how you can tell. Like I just said, the angle which the graph of the red car is making is this. Let's call it theta 1. And the angle made by the blue car is this, theta 2. Clearly theta 2 is greater than theta 1. The angle subtended by the graph of a blue car is greater than the angle subtended by the red car. So clearly blue car has greater speed. Blue car has greater speed. Okay. Question number 10.5. The distance time graph below represents the part of the journey of a train. Study the graph and answer the following questions. Now have a look at this graph. The distance is in meters and the time is in seconds. How far did the train travel in 50 seconds? Now in order to check that, we have to first note where 50 seconds is lying. This is the point. Drop a perpendicular, and in order to find the distance corresponding to this time, you drop a perpendicular on the y-axis. The point at which it cuts the y-axis will be your distance. So that would be 2000 meter or 2 kilometers. That's simple. Okay. Calculate the train's average speed. Show your working. In order to find the speed, I must know the distance, I must know the time, and I'll divide distance by time. Now have a look at this point. At this point, if you want to know the distance, what you are going to do is you drop a perpendicular on the y-axis. Okay, so distance is 2000 meters. In order to find the time, you drop a perpendicular on the time axis, which is the x-axis. It cuts it at 50 seconds. This 0 and this 0 goes. 5 1 are 5, 5 4 are 20. So speed would be 40 meter per second. Fine. Now you notice one thing here. This is a straight line graph. Fine. So it represents the journey of a train moving with a constant speed, moving with a steady speed. Fine. Now it doesn't matter which point in the graph you take, you'll still get 40 meter per second. Uh, that's no magic. Let's take this point. What do you think the distance at this point is? Drop a perpendicular on the y-axis, it will cut it at 1000 meters. Fine. So let me check. So speed is 1000 meter, distance is 1000 meter. What is the time at this particular moment? I think this is your time. This is your time. So 20, 21, 22, 23, 24, 25. So 25 seconds. Can easily evaluate this. 25 1 hour, 25 40 hour, 1000 meter per second. So that is 40 meter per second. Again, magic? No, mathematics. Okay, any other point you want to take is entirely up to you. Let's take this final point. Okay, at this point, the time you can clearly see it's 60. It's 60 seconds. Okay, what about the distance? The distance is this. Okay, 20, 21, 22, 23, 24, 100 meters. So this 0 and this 0 goes, 6 1 are 6, 6 4 are 24. Again 40 meter per second. Magic, right? Okay, so yeah, this is exactly what I was trying to explain in this question as well. Fine. Speed represents is represented by the slope. If the speed is constant, the graph would be a straight line. Right? It's going to make same angles throughout, because I have explained it in Sunday classes as well, that speed can be expressed as tan of theta, but that is something I'm not going to touch here, and only those who attended Sunday classes would understand, and I do not want grade 7 students to get confused. Fine, so I'll be stopping here. If you have any confusions, if you have any feedback, any kind of comments, please tell us, please let us know in the comment box below. And if you have got any other doubts, any other confusions, do not hesitate to email us. Thank you very much. Best of luck.